All right, in our third example here, we'll go ahead and take a look at something that's a little different looking. In this case, we have two equations and three unknowns for our system that this particular matrix represents. And we'll go ahead and solve this out. It won't take too long because there aren't a lot of steps here. But as usual, we look for a 1 in position 1, 1 to get us started. It already is. And then we'll make everything else in that column into a 0. So this will be pretty straightforward. We'll get a new matrix that has the same first row. And the second row now we'll create by taking -2 times the top row and adding it to the second row. So -2 times row 1 plus row 2. And we get -2 and 2, which is 0. We get 2 minus 2, which is another 0, -2 and 3, which is 1, and -8 and 2, which is -6. And we can do one more step here in terms of finding our reduced echelon form, and that is that I could multiply row 2 times -1 and add it to row 1. And that would zero out this position here. So 0, 0, 1, -6. And now we'll go ahead and take a new top row to be -1 times row 2 plus row 1. And we'll get a new top row, which will look like 1, -1, 0. And again, we're doing -1 times that bottom row. So I'm going to get a +6 and a 4, which is going to give me 10. So now we've got our reduced echelon form for our matrix. There's no further calculations we can make here. And we can go ahead and interpret what the results say. So this top row is telling us that x1 minus x2 equals 10. And the bottom row is saying that x3 is equal to -6. So again, we end up with a free variable. This time it's looking like x2. So we make x2 equal to x2. We recognize that primarily because there's no leading 1 in the x2 column. So this is where the x2 column is. There's no leading 1 there. I have a leading 1 here on x1, and I have a leading 1 here on x3, but there isn't a row that represents the leading 1 on x2. So that we know that's our free variable. If, for example, just hypothetically, if these were reversed and it reduced to this, now I've got a leading 1 here and leading 1 here for x1 and x2, but no leading 1 for x3, which means that x3 would be the free variable in that scenario. But that's obviously not what we had. So this is what we get. And again, we want to rewrite everything in terms of that free variable. So x1 is going to be equal to 10 plus x2, or x2 plus 10, either way. x2 is our choice, and x3 is fixed at -6. So this is the set of solutions to the system that matrix represents again.